Hi students, welcome to my YouTube channel. In this video, we'll learn introduction of probability. Introduction of probability. Observe 1. We take a decision by guessing the future happening, that is whether an event occurs or not. We take a decision by guessing the future happening, that is whether an event occurs or not. Our decision comes true and sometimes it may not. We try to measure numerically the chance of occurrence or non-occurrence of some events, just as we measure many other things in our daily life. This kind of measurements helps us to take a decision in a more systematic manner. Therefore, we study probability to figure out the chance of something happening. What is probability? Probability means possibility. Probability is a measure of the likelihood of an event to occur. Probability theory is nothing but common sense reduced to calculation. This one is definition by Pierre Simon Laplace. It is a branch of mathematics that deals with the occurrence of a random event. Many events cannot be predicated with total certainty. Types of probability. Probability is two types. One is the theoretical probability. Second one is the experimental probability. Theoretical probability and experimental probability. Experimental probability. For example, it is based on the basis of the observations of an experiment. The experiment probability can be calculated based on the number of possible outcomes by the total number of trials. For example, the experimental or empirical probability of an event E is defined. The formula probability of E equal to number of trials in which the event happened divided by total number of trials. Number of trials in which the event happened by total number of trials. If a coin is tossed 10 times and heads is recorded 7 times, the experimental probability for heads is 7 by 10. Here 7 is the happened number of heads happened, total number of trials 10. So therefore the probability, experimental probability is equal to 7 by 10, that is equal to 0.7. Consider an experiment. Another experiment. A normal coin was tossed 1000 times. Head turned up 455 times and tail turned up 545 times. Head is 455 times. Tail turned up remaining 545 times. If we try to find the likelihood of getting heads, we may say it is 455 out of 1000 or 455 by 1000, that is equal to 0.455. This one is the experimental probability to get head. If we perform the same experiment for another 1000 times, we may get slightly different data, giving different probability estimate. Many other persons from different parts of the world have done this kind of experiment and recorded the number of heads that turned up. The 18th century French naturalist Comte de Buffon tossed a coin 4040 times and got 2048 heads. The experimental probability getting head 2048 by 4040, that is equal to 0.507. Another scientist, J. E. Kerrich from Britain, recorded 5067 times heads in 10,000 tosses of a coin. The experimental probability of getting a head 5067 by 10,000, that is equal to 0.5067. Another scientist, statistician Carl Pearson, spent some more time making 24,000 tosses of a coin he got 12,012 heads. The experimental probability of getting a head 12,012 by 24,000, that is equal to 0.5005. Observe here the evaluation of the result approximately value 0.5. Second one is also 0.5 something. Third one is also 0.5005. These are nearby to 0.5. Next one, theoretical probability. It is based on the possible chances of something to happen. The theoretical probability is mainly based on the reasoning behind probability. The theoretical probability of event T is equal to number of outcomes favorable to T divided by number of all possible outcomes of the experiment. Favorable outcomes by total outcomes. For example, if a coin is tossed, the theoretical probability of getting a head will be 1 by 2. Coin is tossed, the theoretical probability getting a head is equal to 1 by 2. So total outcomes 2. One is the tail, one is the head. Head is only one time, so therefore the getting a head is equal to 1 by 2. Next one, observe here. This one is my Android app, Satvir Academy. In this app, class 10th to class 8th and Telemedium and English medium students also use this app. In this app, TS or AP, Polyset, RJC set students also study material, videos available in this app. Observe here. Okay. Please download and install your mobile. Next one, this is my website satvir.academy.com. Academy.com. In this subset also class 10th English medium students study material, RJC, Polyset, IIIT, entrance exams, MCQ, multiple choice questions, study materials, notebooks available in this website also. Formulas. Okay. Please follow my website. Next one, experimental probability versus theoretical probability. Generally, before the experiment, we estimate its theoretical probability. But after experiment, we can find that there is difference between experimental and theoretical probability. If the experiment is done for more times, then the experimental probability closes to the theoretical probability. The probability formula is defined as the possibility of event to happen is equal to the ratio of the number of favorable outcomes and the total number of outcomes. So probability of E equal to number of favorable outcomes of E by number of total possible outcomes. Random experiment. An experiment which can be repeated a number of times under the same set of conditions and the outcomes are not predictable is called an experiment, random experiment. The outcomes of random experiments may be equal likely or may not be. Sample space. The set of all possible outcomes is called the sample space. A sample space is usually denoted by S using set notation, and the possible outcomes are listed as elements in the set. Example, for tossing a coin, the sample space in the set symbol braces head, tail. For tossing two coins, sample space head, tail, tail, tail. Okay. For tossing a single six-sided die, sample space is set of elements 1, 2, 3, 4, 5 and 6. Next one, equal likely outcomes. When the events have the same theoretical probability of happening, then they are called equal likely events. When the events have the same theoretical probability of happening, then they are called equal likely events. Example, if an coin is tossed, then each outcome is equal likely to happen. Mutually exclusive events. If a coin is tossed, we get head or tail, but not both. Similarly, if we select a student of high school, that students may belong to one of either 6th class, 7th class, 8th class, 9th class or 10th class, but not to any two or more classes. Two or more events of an experiment where occurrence of an event prevents occurrence of all other events are called mutually exclusive events. When we toss a coin or roll a die, we assume that the coin and the die are fair and unbiased. When we toss a coin or roll a die, we assume that the coin and the die are fair and unbiased. Thank you students. Like, share and subscribe my YouTube channel. Next video we solve questions